Scientific notation. So it's a type of notation for very large and small numbers are the main uses. So for example, there's a lot of research going on now into what they call nanotechnology, which is a very small scale on the molecular level. And for example, a nanometer is a billionth? Oh, I forgot. Billionth or a millionth? One of those. It is a billionth of a meter. One billionth of a meter. So let's think about place value for a second. 1 nanometer, let's call it NM for nanometer, would be 0 point, so let's see, we've got tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions. So again, that is 1 over 1 billion. So a billion has how many zeros in it?
9.
9, yeah, that's one reason I wrote the fraction underneath here, so you can see the 9 zeros there. So I could write this as 1 over 10 to the 9th power. Is there another way I could write that in terms of powers?
One over negative 9?
Almost.
1 to the negative 1.
Almost. No. Keep the base. 10.
Negative 9, right?
10, yeah, to the negative 9. Yeah, so another way to write this
nanometer
would be 10 to the negative 9th. In scientific notation, usually in scientific notation, there's some number times some power of 10 is the way scientific notation usually is. So for a nanometer in scientific notation, I would write it as 1 times 10 to the negative 9th. So that would be 1 nanometer in scientific notation. Trying to get the zeros right?
Yeah, so what I was looking at is, so when it goes to the negative 9, it's 8 zeros, right? Because the 1 is taking the place.
The 1 is taking one of the places up.
Okay.
Yeah.
All right.
That's because there's not a ones place.
Yeah. Okay.
Yeah.
Just making sure.
Yeah. Yeah. Remember, the ones is the center of our number system, and that's important. So it marks the middle of the way we write numbers, not the decimal point, which is kind of weird, but it's just the way it is. So often, you know, writing something down like a billion, it's easy to miss the zeros. So I'll often like double check by counting those places out. And you notice when I wrote the zeros, I counted every single place to make sure I got it right, which takes a little practice. Just a little bit of information about scientific notation. This number right here, the one I wrote right there, is called the mantissa. Out well, my pen is not tracking. Try again. Mantissa. And the mantissa has to be between 1 and 10, but it can't be 10. So write that down on the next page. So the mantissa could be 1, but it's got to be less than 10. What that means is you can only have a single digit to the left of the decimal point. So I'm just going to pull up an example of another place we use scientific notation. So every year, not every year, but most years, our United States government spends more money than they take in through revenues, and so we get a deficit. That's what happens each year. And when you add up all those deficits, we get an accumulated debt. And the current debt of the United States government is $22 trillion. Okay. So we're going to write that number in scientific notation. First, we're going to write it in regular notation. So example, 22 trillion. I can spell. So let's think about that. So without the word trillion, I got to throw in a bunch of zeros. So 1, 2, 3, that gives me 22,000. Another 3 zeros gives me 22 million. Billion. Ah, there we go. Now I have trillion. So that's that number. To put this in scientific notation, to do it properly, I want the decimal to be right between the 2's, because for the mantissa to be right in proper scientific notation, you can only have 1 digit to the left. Because you got to have a number that's between 1 and 10, but it's going to be smaller than 10. So that's going to give me a 2.2 times 10 to some power. And 13. So the decimal was unwritten over there on the right. So we're going to move 3, 6, 9, 12, plus 1 more would be the 13th power. So 2.2 times 10 to the 13 is another way to write our national debt. So we could call it 22 trillion with the word trillion. We could call it 22 trillion with a whole lot of zeros and commas to help us mark them. Commas are essential. Or we could call it 2.2 times 10 to the 13th. Now, a trillion has how many zeros on it? Just a trillion, 1 trillion. 12 zeros. So I could take this original version of the number above, and I could say it's 22 times 10 to the 12th, because a trillion is 10 to the 12th. Question, is that green number in scientific notation? The answer is no, because the mantissa doesn't fit that description right there. So this is what's called pseudo-scientific notation. It's almost in scientific notation. It kind of looks like it, but the base number doesn't work right. So scientific notation is a little picky in that we need to get the decimal in the right spot so that there's only 1 digit to the left of the decimal point. There isn't a decimal point written here, but if we wrote one, it would go right there. I have 2 digits to the left, so it's not scientific notation. That's the rule. Somebody made that up a long time ago. We use it. All right, so just playing around with scientific notation a little bit. Often we have to multiply or divide numbers in scientific notation. So we're just going to do a quick example of that. So I'm kind of curious how much bigger is the sun in the sky than the earth that we stand on?
32.
What is it? You're just making a big guess?
Yep.
It's yeah, so we're going to play around.
There's a 3 and a 2 in it.
So I was thinking, all right, like how, like the earth's a big ball, So maybe if I know the radius of the Earth, that might help. So I looked up a couple of things, and according to NASA and Wikipedia, the radius of the sun is sun radius about, let's see, I lost it, where'd you go? Did I get that right? The radius of the sun, oop, wrong number. There we go. 695 million thousand kilometers. 695,000 kilometers. There we go. That's the sun. The Earth's radius is about 6,000 kilometers. I'm rounding quite a bit. So let's see, if I divide out the thousands, then 6 goes into, this is more than 600, but it's more than 100 times the radius, right? So we could throw that into a calculator and see what we get. So let's just do that for fun. Calculator, come here, calculator. 695 divided by 6, I get about 116 times. But are we doing good math? So I could make a note here. After dividing these two, the sun's radius is about 116 times the Earth's radius. So just a rough, very rough scale drawing. Let's say this is the sun over there. I have to draw an Earth that's like around 1/100th as wide. So that little dot over there would be about the Earth. Now, that's just how many Earths would line up to get across. So if I lined up 116 Earths, they would go across there, butted up against each other. Does that answer my question up here? No. So that only takes a consideration like the equator of the sun and the Earth matching up. There's all this other space out here. There's all this other space that fills up these big balls. So what do I really want to look at to compare their sizes? Not their radius, not their diameter, not their circumference either. The circumference would just give me a ring around. Here I'm just cutting straight through the middle. Turns out I need their volumes to figure that out. Okay, so let's do a quick test of what happens there. So we'll deal with this next quarter, but the volume of a ball, which the Earth and Sun are kind of big balls. Anybody know the technical term for a ball?
Sphere.
A sphere is 4/3 times pi times the radius cubed would be the volume. So we're going to figure this out for the Earth and the Sun and see what we get. So for the sun, not sum, I want to take 4 divided by 3 times pi, and then I'm going to take that, what was it, 695,000 kilometers, and cube it. And then we'll do the same thing for the Earth. 4/3 times pi. And the Earth was, I estimated to be about 6,000 rounded kilometers cubed. And these are the two numbers that we want to divide to compare their sizes. So let's see if we can come up with a rough estimate of each of those. And these are rough for a variety of reasons. One, we're rounding numbers. Two, neither the Earth nor the Sun are perfect spheres. All right, so Sun, 4/3 times pi. And on the Google calculator, you can just type pi for pi, which is kind of cute, times 695,123 raised to the 3rd power. And I get scientific notation. So this is an interesting thing on calculators. 1.4061868 e plus 18. Have you ever seen that e plus thing before? Can you remember what it means?
No, exponential.
It's not e the exponential number. It just means that's the power of 10 that comes next. Okay. So it's an engineering type notation. Some calculators give a capital E instead of a lowercase e. So another thing to think about is the numbers that I gave you. Have you ever heard of significant digits? Here we go. Significant digits means how many digits in your starting numbers are important. So I rounded this number, so the radius I gave for the Sun had 1, 2, 3 significant digits. Zeros on the outside are not significant. How many significant digits does the radius of the Earth have?
6.
Just the 6, so there's 1 significant digit. When you do calculations in science, the standard is your answer should have no more than the smallest number of significant digits in any value in the calculation. In which case, how many significant digits does our answer have?
1.
Just 1. Yeah. So based on these numbers, the way they're stated, if I was asked to state my answer with significant digits, then I would have to say the answer is 1 times 10 to the 18th power. That's using significant digits. So back here, I'm going to say the red number is approximately, red number, 1 times 10 to the 18th power. Now, this number up here was in kilometers. I just cubed kilometers, so this gives me an answer in cubic kilometers, which sometimes we write as kilometers cubed. Would be another way to write it. Same calculation for the Earth. So that's going to be 4/3 times pi. And what's next? Times 6,000 raised to the 3rd power. And this one didn't give me scientific notation, unfortunately, but I only get to use the 9 if I'm going to stick with significant digits, and then we just have to count over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what? Thousands, millions. So this is 900 billion. Did I get that right? 1, 2, 3. Let's copy and put some commas in it. Make sure I got it right. And 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah. So if we write this in scientific notation, so again, thousands, millions, billions, 900 billion in green would be 9 times 10 to what power? Almost.
13.
Too far? 11? Yeah, so we have 3, 6, 3, 6, 9 plus 2 more, so it'd be 10 to the 11th power. So now if we want to answer the question, how many times bigger is the Sun than the Earth? you're going to put all that together. So how many times bigger is the sun than the Earth? I want to take the sun's volume and divide by the Earth's volume. So that's going to give me 1 times 10 to the 18th divided by 9 times 10 to the 11th. So whip that out on a calculator, see what you get, see if we can agree on that. Several ways to enter this into a calculator or write it on paper. And we're going with only one significant digit here. So what would the answer be to one significant digit? Anybody have a guess? So quiet, okay? I'm going to stop the recording here and let you guys figure it out. Check back in the near future for an answer.